Okay, so here's another possibility for an angle. When you see an angle with no degree symbol on it, it's said to be in radians. So typically radians is going to have a pi symbol, but it doesn't have to have a pi symbol. If it just said, let's say 2, it didn't say 2 degrees, it just said 2, that'd be 2 radians. Now with that in mind, 360 degrees is the same as 2 pi radians. That's the relationship, the equivalence between the two things. So if we have an idea of, going back to the degree formula that we had a moment ago, so I know that the arc length equals the central angle. I'm going to put maybe, let's go C for central angle, over 360 degrees times 2 pi r. If the angle's in degrees, that's how you do it. If 360 degrees and 2 pi radians mean the same thing, if I'm in radians, so again, this is the degree formula. If I'm in radians, let's just see how the formula works out. So the central angle still has some measure. In this case, it's 3 pi over 4, whatever. It is what it is. But C is the central angle in radians this time. But instead of 360 degrees in the bottom, 2 pi radians is all the way around the circle, so I put 2 pi down here. That's being multiplied by 2 pi r. Now officially 2 pi r, since it's not fractional in structure, is in the numerator of a fraction. And this fraction, c over 2 pi, is being multiplied by this fraction, 2 pi r over 1. The 2 pi on the bottom and the 2 pi on the top are exactly the same thing, so they cancel, leaving us with a very simple formula for radian arc length. We take the central angle measure in radians and multiply it by the radius length. Okay, with that in mind, this number is 3 pi over 4 radians. That's what equals C, that's the central angle. And 6 centimeters is the radius. And the formula says I simply have to multiply this times this to get the arc length. So S equals 3 pi over 4 times 6. Once again, it says round to the nearest tenth. Once again, there's a pi happening in the problem, so I'm probably going to use 3.14 to approximate. And once again, I've got multiple things being multiplied divided by one thing. So if we're entering a calculator, I'm going to type in 3 times pi, which I'm going to replace with 3.14, times 6, all the top stuff being multiplied and then divided by the bottom number last. So 3 times 3.14 times 6 divided by 4 equals, and it spits out 14.13. Nearest tenth would be 14.1. And that's going to be centimeters. So in your homework, when you're doing arc length, you need to question, is the angle given to me in degrees? If so, I need to use that formula. Is it given to me in radians? In that case, I need to use this formula. Apply the proper formula, and then again use the calculator technology in order to evaluate what it is you write down. I'd want to see on your paper where you've established this radians and degrees that you make a clarification that I know that you know that that's important. That you apply the proper formula based on that thought, and then where you evaluate it, and I'll give you the answer to the nearest tenth.